All right. So we talked about law of sines.
Is that ambiguous case?
Okay. And the ones we did, yes, that is ambiguous case. All right. Ambiguous means there's more than one possible interpretation or one possible answer, basically. Okay. The problems I gave you for law of sines last time, all of those problems, there was only one way to answer the question. There was only one way to solve the triangle. Because I gave you two angles and a side. Okay? The ones that I assigned last time all had two angles. You were given two angles and one side. Okay? There's only one possible triangle then that you could draw. Okay? Unfortunately, if they give you two sides and an angle that's smaller than 90, sometimes there can be more than one solution. Okay? And this is the really tricky part about law of sines. Okay? When is there going to be two solutions? When is there just going to be one solution? Could there be no solutions based on the information that I give you? Okay? This is where it gets a little bit tricky. Okay? So I'm going to do my way of trying to show you when there's zero, when there's one, when there's two solutions. Okay? So, here's one. This one will have two, I'll just tell you. Alright? So save a lot of space. Side A is 40, side C is 60, and angle A is 51 degrees. Okay. Notice you're given an angle, and you're given two sides. Okay? You're given an angle, and you're given two sides. This is an instance where there could be more than one solution. So how do you know if there is? That's what I'm going to try and demonstrate here. Okay? When you're given an angle and two sides, draw the bottom left part of a triangle, or the bottom left corner of a triangle, and put the angle in that bottom left corner. Okay? So I would do something like this. And I try to draw it somewhat to scale. Okay? Then, notice the angle that was given was angle A. Side A would be opposite that angle, right? Side A is opposite angle A. Don't draw that one in quite yet. Okay, don't draw that third side of the triangle. Give the other side kind of the top part of it. So I'm going to give this a 60 right here. Okay? It's supposed to be 60. Make sure I got that right. Oh, my bad. It's supposed to be 50. It's supposed to be 50.
Oh.
I know.
Really?
Alright? Okay. Now, how could there be more than one possible answer? So I wouldn't draw anything quite yet, because there's going to be a few things that I'm going to talk about and put up here, okay? And then you can kind of determine what you need in your notes from there. Alright, I'm going to drop a perpendicular down to this other side. Okay? And we'll call that H for right now. Because I dropped a perpendicular, you could use SOHCAHTOA, right? Sine of 51 equals H over 50. You guys agree? Okay. So sine of 51 equals H over 50. So then H equals 50 times the sine of 51. And then I could use just a little bit of help here from people with calculators. 50 times the sine of 51. 38.86. Okay. Now here's the key part where you really have to follow along and follow my reasoning. Okay? Alright. They gave us angle A as 51 degrees. They gave us side A, which would be the side across from the 51, as 40 units long. Okay? if this were a right triangle, side A, this is the side across from the angle 51, side A would have been 38.86 units long. Agreed?
Yep.
If this were a right triangle. Because we used SOHCAHTOA and we figured out what that height would be. But unfortunately, A is, in this case, longer than what the height would be, right? So in this case, A is greater than what we figured out the H value would be. So then what you're looking at is this side, if I were to drop it straight down and not connect it, it's a little bit longer than what the height would be. You guys still with me? Now obviously we don't have a triangle that's formed right now. We know this is 50 and we know this right here is 40, but that doesn't really connect to make a triangle. So let's kind of pretend this blue dotted line here is, or a segment here, is something we could swing. Alright, so I'm holding it right here and I could just swing it back and forth if I needed to. Okay? Right now, dropping it straight down, it's too long, right? But if I swing it back to the left, eventually, as I swing it back this way, it would touch this bottom side of the triangle. You guys follow that? Everybody? Questions? Speak up if you have it. Or I could swing it back this way, and it could potentially touch over there as well. That side that's 40 units long. So that's where our two triangles could occur. You could have one where it comes back towards you like this. So here's 51, here's 40, 40, and here's 50. Having issues. Or you could have one that, instead of coming back towards you, goes away from you. Here's 51, here's 40, here's 50. There's two possible triangles that could have been created because this side they gave you here that was across from the 51, it was too long to make a right triangle. So then if you swing it this way, you kind of create one of these looking triangles, a smaller one, or it could be swung that way. We don't know for sure. We don't know which triangle, so there's two possible answers to this situation. There's this small triangle, and then there's this little bit bigger triangle. Thoughts, questions so far?
When would there not be two?
What's that?
When would there not be two?
When would there not be two? Okay. First of all, there would be one if the value they gave you for A, the side across from the 51, there would be one if the value they gave you for A was exactly this 38.86 whatever. Then there'd only be one possible triangle, and that would be the right triangle. Okay? Now what if the value they gave you for A was 35? No triangles. If this is only 35 units long, here's the third side of the triangle. Oops, I can't even make a triangle, the side's not long enough.
But how do you know in units how long? Just
Do the math.
You can always, you kind of pretend it's a right triangle and see what the height would be if it were a right triangle.
okay, okay.
If your answer, if the other side is bigger than this, it could swing either way and there's two triangles. If the side opposite the angle is exactly this, then that's just your one triangle, that right triangle. And if it's shorter than this, well then they messed with you and they gave you what's not possible. You couldn't even create a triangle. Does that make sense? So really what you're going to do every time, guys, is you're going to see what would the height be if it were a right triangle. So you're going to put your angle here. Don't put that other side in, the side across from that angle, and then put the other one as your hypotenuse and figure out what the height would be if it were a right triangle. And then based on that number, based on that 38.86, then look at the other side. It's 40. Well, it's bigger than this, so I could have a swinging gate. It could go smaller, it could go bigger. Okay? If it's shorter than this, no triangles are possible. I'll just go ahead and tell you right now, you're more likely gonna have the two solution one and not a no solution one. Okay, questions on that? Isaac?
We always choose the solution one now, how do we figure out, like, from there?
I'll go into the two solutions of how, yep. But I want you to understand how that's even possible based on our given information. That's where I want you to be right now. Everybody good on that?
Yep.
Lizzie, would you pause it real quick? 'Cause if I get over 15 minutes, it won't